The world before the catastrophe. Imagine Earth 70 million years ago. The planet is a dinosaur planet, a realm where cold-blooded giants dominated every ecosystem. From towering sauropods seasoning the treetops to swift raptors patrolling the plains, dinosaurs weren't mere street performers. They engineered entire food webs. Land. Massive herbivores like Argentinosaurus and Brachiosaurus grazed on prehistoric forests. Carnivores like Tyrannosaurus rex ruled apex predator roles, aided by packs of smaller hunters. Skies. Pterosaurs glided overhead, ruling the aerial niche. Oceans. Mosasaurs and plesiosaurs held court in marine realms, alongside ammonites and ancient fish. In this world, mammals existed but as tiny underdog creatures. They tucked themselves in shadows under brush piles, beneath dinosaur footprints, or in burrows. 2. Mammals in the Age of Beasts. During the Age of Dinosaurs Mesozoic era, mammals were small, often no larger than squirrels or rodents. Most were nocturnal insectivores. Their survival strategy hinged on avoiding dinosaurs. They scurried out at night, nibbled on insects and seeds, and stashed food to last through harsh seasons. Brain power was limited but sufficient. Every gram of tissue had to justify itself in survival terms. The constant threat of predation shaped their evolution. Ecological niches were narrow and heavily controlled. Mammals weren't apex or niche disruptors. They served as background operators. This ecosystem dominance by dinosaurs created a near impenetrable barrier. Mammals couldn't grow large, couldn't branch out into new habitats, and certainly couldn't evolve complex social structures or intelligence. 3. The asteroid that changed everything. Then, 66 million years ago, Earth's history pivoted on a 6-mile-wide asteroid. When it struck what is now the Yucatan Peninsula, the aftermath was apocalyptic. An unimaginable release of energy, billions of times the power of Hiroshima. Thick layers of dust, soot, and debris launched into the atmosphere, blocking sunlight, triggering global wildfires, collapsing photosynthesis. Within weeks or months, the surface temperature dropped drastically. Acid rain reshaped river systems. Ecosystems fell apart. The consequences were swift and brutal. 75% of all species vanished. Among them, every non-avian dinosaur disappeared. Their extinction echoed across food chains. Without dinosaurs, ecological niches lay open, waiting for new occupants. 4. A mammalian world emerges. With dinosaurs gone, mammals seized their chance. Larger body sizes became possible thanks to reduced predation. Diurnal shifts occurred. Animals emerged during daylight, exploiting photosynthetic webs. Diversification exploded. Mammals evolved into rodents, ungulates, carnivores, primates, and more. Brains grew. Socially complex groups, behavioral flexibility, and intelligence became advantageous. Some of those mammal groups incubated the precursors to humans. Primates wouldn't exist without that widespread diversification. 5. Why dinosaur absence was critical. Think of ecology as real estate. Niches are plots of land. Before the asteroid, dinosaurs owned the residential, industrial, and commercial sectors. Mammals existed only in the cracks. Once dinosaurs were gone, the ground layer, herbivore niches vacated, so mammals could expand from deer to elephants to giraffes. The forest edges. Primates began evolving features like grasping hands and forward-facing eyes. Without dinosaurs, the insurance policy against large, cold-blooded conquerors wasn't just lifted, it was cancelled. 6. Could intelligent reptiles have evolved? Something like a dinosauroid, a hypothetical intelligent dinosaur, has been envisioned. Paleontologist Dale Russell sketched a creature that walks upright with human-like intelligence. But realization is unlikely. Dinosaurs lacked an evolutionary roadmap toward tool use or social complexity like primates. There was no trend favoring big brains, just efficient predator or prey roles. Their physiology might have limited what they could evolve cognitively. Warm-blooded mammals adapted more easily to shifting environments. The rubble left by the extinction event might have stunted any reptilian progress. Intelligent evolution takes time and ecological consistency. In short, evolution didn't tend toward smarts for dinosaurs. Even if one species had shown flair, the odds of seeing where Homo sapiens went are against us. 7. The takeaway so far. Mammals were real but suppressed. Only rodents and insect wolves, with no chance of branching into apes. The asteroid extinction was a zipper. When it unzipped, ecological layers blew open. Humans exist by cosmic lottery. Our evolution rides on an extinction-level reset. In this alter-Earth view, humans owe our existence not just to small adaptations but to large catastrophes. Without the asteroid, our future, and indeed existence, would have been a different story altogether. From shadows to dominance. Once the non-avian dinosaurs were gone, the ecosystem was a clean slate, and mammals took full advantage. In just a few million years, mammals diversified into every major land niche. Some became fast-running herbivores, early ungulates. Others became predators, ancestral carnivores, and some climbed trees and developed grasping limbs, primates. This radiation was rapid by evolutionary standards, an explosion of diversity known as the Paleocene-Eocene adaptive radiation. Before the extinction, mammals were mostly shrew-like creatures. Within 10 million years after the KPG event, Earth was full of proto-deer, hyena-like scavengers, and gliding tree mammals. This wouldn't have happened if dinosaurs still held their ground. Apex reptiles left no space for apex mammals. 2. The birth of primates. Among the climbing, insect-eating tree mammals were the early primates. Their development marked the slow but steady start of the human lineage. Key traits that evolved in this branch: grasping hands and feet for climbing trees, binocular vision for depth perception, larger brains relative to body size, longer childhoods, and more parental care. These adaptations didn't emerge for intelligence's sake, but they created the hardware intelligence would later run on. By the Eocene, 56 million years ago, we see primates like adapiforms, lemur-like, social, and agile. They still looked nothing like humans, but they were on the path. 3. From forests to savannas. Fast forward to 10.7 million years ago, the climate changes again. Tropical forests shrink. Grasslands and open savannas expand, especially in Africa. Arboreal primates either adapt or vanish. One lineage of ground-dwelling primates begins walking upright. It's not because of a plan. It's a response to a new survival challenge. Walking upright frees hands for tools, saves energy, and offers better vision over tall grass. Thus begins the story of hominins, our earliest direct ancestors. Would this evolutionary push have happened with dinosaurs still ruling? Almost certainly not. Dinosaurs would have claimed that ground long ago. Primate evolution was conditional on absence of danger, of predators, of competition. 4. From hominins to humans. The hominin branch included species like Australopithecus afarensis, Lucy, Homo habilis, tool-using human ancestor, Homo erectus, fire user and global migrant, Homo sapiens, us. Each evolutionary step layered complexity. Tool use escalated. Social learning exploded. Symbolic thinking, language, and culture emerged. All of this took tens of millions of years, on a timeline that would have been impossible if dinosaurs were still blocking mammalian advancement. 5. In the shadow of dinosaurs, the what if. Let's flip the script. If non-avian dinosaurs hadn't gone extinct, here's what primate evolution would have faced. Constant predation pressure from fast, agile theropods. No access to large-bodied niches. No evolutionary benefit to developing complex social brains. No control of land ecosystems. Territories claimed by sauropods, ceratopsians, and hadrosaurs. Even if small primates existed in treetop zones, it's unlikely they would have developed the social, cognitive, or physical capabilities to evolve into tool-using apes. They would have hit a dead end. 6. Could intelligent dinosaurs have replaced us? It's a fascinating idea, and one worth examining. Some paleontologists point to the trudontids, small, bird-like dinosaurs with unusually large brains. They had stereoscopic vision, grasping claws, and may have been relatively intelligent. Dale Russell proposed the Dinosauroid in 1982, a speculative evolution of Trudon that could have developed humanoid traits over millions of years: upright walking, larger brain capacity, complex social behavior. But here's the problem: there's no solid fossil evidence of intelligence trending upward among any dinosaur clade. Evolution tends toward what works, not what's smart. And dinosaurs were already successful without intelligence. It took mammals tens of millions of years after the extinction to evolve high-level cognition. Dinosaurs had 150 million years and didn't. That said, it's not impossible, just unlikely. If such a lineage had begun, it would have followed a very alien path. Imagine intelligent creatures descended from pack-hunting predators, not tree-dwelling apes. Their society might be colder, more hierarchical, less emotional, pure speculative gold for alter-Earth fiction. 7. Could both coexist? Another idea: what if mammals and dinosaurs co-evolved, side by side? In this version, mammals evolve slowly in parallel ecosystems, perhaps in cold climates or isolated continents. Eventually, intelligent primates appear, but they share the planet with advanced dinosaurs. Think Homo sapiens building fires in one part of the world, while feathered reptilian civilizations rise in another. The odds are low, but it makes for an incredible sci-fi setting. Brain summary: why humans needed dinosaurs to die. A thought experiment: the Dinosauroid. The most famous concept of an intelligent dinosaur is the Dinosauroid, proposed by paleontologist Dale Russell in 1982. Russell speculated that if a small, brainy dinosaur like Trudon had survived the mass extinction and continued evolving, it might eventually develop upright posture, large cranial capacity, dexterous hands with 3 fingers, internal gestation like mammals, vocalization for complex communication. Is that realistic? Let's unpack the plausibility and the world it might have built. 2. Could a dinosaur really become intelligent? White heavy checkmark the case for they had keen senses, excellent vision and hearing. Their fossils suggest agility, social behavior, and possibly even nest-guarding signs of cognitive development. Intelligence has evolved multiple times in nature. Cephalopods, birds, dolphins, and primates. It's not a one-off trick. Crossmark the case against dinosaurs were extremely well adapted as they were. Evolution doesn't push for intelligence unless it gives a major survival edge. There's no fossil trend showing brain expansion in dinosaurs like what happened in mammals. Reptilian biology is less favorable for sustained brain growth. Slower metabolism, less parental investment, and minimal social learning. Conclusion: not impossible, but far from guaranteed. You'd need the right evolutionary pressure, isolation from larger predators, and a climate that rewards brain over brawn. But if the conditions aligned, an intelligent dinosaur could arise, just not in the exact way we did. 3. What would a Dino-sapien civilization look like? Assuming one species of advanced dinosaurs developed intelligence, tool use, and communication, let's imagine their world. Biology and physiology: cold-blooded or mesothermic. Their energy use and metabolism might be more efficient, but limit activity in cold climates. Scaly skin, possibly feathers. No hair, no sweat, less insulation. Egg-laying or ovoviviparous. Parental care could be minimal or highly ritualized. Horizontal pupils or ultraviolet vision. Seeing the world in a fundamentally different way. Split vocalization like birds or reptiles. Complex calls or mimicry, not human-like speech. Society, territory-based social orders. Many reptiles are solitary and territorial. Social cooperation would have to evolve independently. Ritualistic behavior. Communal nesting or seasonal gatherings might spark the early seeds of shared knowledge. Emotionally cold, but highly logical, empathy might not drive bonding. Survival or efficiency could dictate relationships. Low reproduction rate. Long development cycles, slow growth, and fewer offspring could lead to more investment in each individual. Technology, tool use without fire. Reptilian evolution may not prioritize fire if body heat isn't a major issue. Metalworking would require a cultural leap, but not impossible if they learn to manipulate energy. Architecture could be subterranean or cliff-dwelling to match cold-blooded needs. Written language could evolve from color signals, body postures, or geometric marks. Their civilization would not mirror ours. It would evolve from a different logic under different constraints and with different goals. 4. The environment of a Dino-Earth. A planet ruled by intelligent dinosaurs wouldn't look like Jurassic Park with laptops. It would evolve over tens of millions of years with new pressures, species, and landscapes. Mammals might remain small or extinct. Megafauna could be mostly reptilian, giant cold-blooded grazers and flying reptile analogs. What would Earth look like today? If the KPG asteroid never hit, non-avian dinosaurs would still dominate Earth's ecosystems. But the world would have changed anyway, just differently. Climate shifts would still occur over millions of years. Ice ages, warm periods, continental drift would reshape habitats. Plants would evolve, forests would rise and fall. But mammals? Most likely still small and marginalized. You'd be looking at an Earth that's biologically rich, but with a totally different cast.
Tinc. No elefants, no lions, no walas, no humans.
2. Dinosaurs would rule the ecosystem hierarchy. With no mass extinction, evolution wouldn't reset. Dinosaurs would stay the dominant form of large land life. You might see sauropod herbivores, hadrosaurs evolving more efficient chewing and digestive systems. Sauropods becoming even larger or more specialized for forest versus open plain feeding. Potential new species with armor, horns, or speed adaptations as predators evolve. T-Rex carnivores, apex predators like T. rex or Giganotosaurus being replaced by even more efficient killers. Smaller, faster, smarter predators filling pack roles like raptor descendants but more refined. Increased specialization for forest hunting, aquatic ambush, or long-distance pursuit. The diversity would be dizzying, a biological arms race continuing for another 66 million years. 3. Birds would still exist and might be advanced. Birds are avian dinosaurs. They survived the extinction and became one of the most successful animal groups on the planet. But in a no-extinction world, they might have evolved differently. More raptor-like birds with claws, teeth, and higher intelligence. Huge ground birds that compete with small mammals, if any exist at all. Gliding and soaring species dominating aerial niches in competition with flying reptiles. It's possible some birds might even evolve intelligent behavior like corvids or parrots have today, but with a 66 million year head start. 4. Would mammals have any shot? Only if they were incredibly lucky and extremely isolated. Maybe in cold regions or small islands where dinosaurs couldn't thrive. They might evolve strange, niche forms. Aquatic mammals, burrowers, or gliders. But primates, with their slow reproduction, complex behavior, and vulnerability, not likely. Any mammalian evolution would be narrow, limited, and cut short if dinosaurs reclaimed the niche. 5. Climate and geography would still evolve. Dinosaurs survived a wide range of environments: hot, dry, wet, even polar. But they never faced the full ice age cycles that shaped mammalian evolution. If they had, cold-blooded species might have gone extinct or evolved insulation, think feathers or even fat layers. Dinosaurs might have migrated or hibernated like modern reptiles. Intelligent species might have had to control heat artificially. A push toward fire, clothing, or shelter, sparking intelligence. Continents would also continue drifting. Africa and Asia would connect. North and South America would fuse via the Isthmus of Panama. India would fully crash into Asia, building the Himalayas. That means dinosaurs would have had access to global ranges, spreading and adapting across every corner of Earth. 6. No cities, no civilization, but maybe something else. Would intelligent dinosaurs build cities? If they evolved intelligence, yes, but those cities would look alien, underground or shaded to regulate temperature. Built from natural materials like stone, bone, or hardened plant resins. Laid out based on instinctive hierarchy or territorial behavior. Fire and metallurgy might take much longer to develop without hands optimized for fine control. Civilization might not spread fast. It could remain localized, slow to change, and more ritualistic than technological. Still, it's possible to imagine Dino-sapien stone temples, communal nesting towers, heat-harvesting architecture, art etched in rock walls scaled not for beauty, but biological memory. Would they invent writing, math, music? Possibly, but it would come from a reptilian emotional core, not the human need to mythologize suffering. 7. What would be missing from Earth? Here's what you wouldn't see in this world. Humans. Our entire evolutionary chain wouldn't exist.
Domesticata animals. No ducks, no cats, no ursas, no cows.
Large mammals. Elephants, whales, bears, apes, all gone or never evolved. Cities with roads, plastics, pollution, skyscrapers. Anthropocene. No trace of human impact on climate or geology. This would be a world of scale, movement, and raw biological power. A place more like an alien planet than anything we know. Could dinosaurs return, and would we survive them? 1. Dinosaurs are gone. Or are they? Let's get one thing straight. Not all dinosaurs went extinct. Birds are living, breathing dinosaurs. Every pigeon, eagle, or chicken is a direct descendant of theropods, the same branch that gave us Velociraptor and T. Rex. But when people talk about dinosaurs coming back, they mean the non-avian giants, the monstrous herbivores, terrifying predators, and ancient beasts that ruled the Mesozoic. So could they return? Let's explore. 2. Could we bring back dinosaurs? This isn't just sci-fi anymore, scientists have already tried.
Option A. The extinction via cloning.
Like Jurassic Park, this requires dinosaur DNA. But DNA degrades fast. The oldest recovered DNA from mammoths is 1 million years old. Dinosaurs went extinct 66 million years ago. Their DNA is completely broken down. Conclusion. No usable dino DNA equals no full cloning. Chicken option 2. Reverse engineering birds. Birds are dinosaurs. Their genes still carry ancient blueprints. Geneticists like Jack Horner are trying to rewind evolution by turning bird embryos into chickenosaurs. By manipulating genes that suppress tails, teeth, and claws, they've created chicken embryos with dinosaur traits. Conclusion. We might be able to make a dinosaur-like animal, but it won't be authentic. It'll be something new. 3. What if we did bring them back? Let's say, somehow we recreated a real T. Rex, Triceratops, or Spinosaurus. Now what? Herb ecological chaos. Dinosaurs evolved in a totally different ecosystem. Our modern plants, prey, bacteria, and climate wouldn't support them. They might starve or become invasive monsters. Warning: public safety nightmare. A T. Rex can bite with 12,000 pounds of force. A herd of hadrosaurs could trample crops, forests, or small towns. Even a peaceful species like Ankylosaurus could wreck vehicles or fences. Microscope ethical dilemmas. Do we treat them as animals or lab creations? Are they protected or patented? What if we create something intelligent? Do they have rights? 4. Could humans and dinosaurs coexist? Not easily. If humans and non-avian dinosaurs existed side by side, cities would need massive defenses or exist in enclosed zones. Travel would be restricted to dinosaur-free corridors. Entire industries would be devoted to tracking, tranquilizing, or containing them. Small towns and rural areas would be vulnerable to roaming herds or predators. Even if they were herbivores, they'd still compete for space, food, and water. Coexistence would be conflict. It's not just about danger. It's about ecological incompatibility. Dinosaurs belong to an Earth that no longer exists. 5. Why we're obsessed with bringing them back. Dinosaurs are more than ancient animals. They're symbols of lost worlds, of power and extinction, of nature unchained. Our fascination isn't just biological, it's emotional. We fear what we lost, but we're also tempted to play God. Films like Jurassic Park, books, games, and documentaries all tap into the same fantasy. What if we weren't the only apex predator? But the underlying warning is the same. Just because we can doesn't mean we should. 6. What dinosaurs teach us about survival. Ironically, dinosaurs still have something to teach us, even in their absence. Lessons.
Dominant seasoned permanent.
The strongest, most widespread species can vanish overnight. Climate and catastrophe rule Earth's history. One asteroid changed everything. Life adapts. Mammals rose because dinosaurs fell. Birds are their legacy. We're not immune. Humanity's survival isn't guaranteed, and we're pushing our luck. Brain final thought. What if we're the next dinosaurs? We look back at the dinosaurs and ask, what if they never went extinct? But maybe we should look forward and ask, what if we do? Will the next intelligent species dig up our fossils? Will they wonder what wiped us out? Climate? Hubris? A war? Will they recreate us in a lab just to see what we were? Maybe in another 66 million years, something will ask, what was Homo sapiens? And why didn't they make it? Clapperboard wrap up the series in perspective. Over this 5-part journey, we've explored how dinosaurs' extinction made our existence possible, why mammals needed an empty world to thrive, what intelligent dinosaurs might have become, how Earth itself would have changed in a dinosaur-dominated timeline, whether we could bring them back, and whether we should. This wasn't just a what if. It was a mirror. Dinosaurs ruled the world. They're gone. We rule the world now. How long will we last?